Hi again. Today I want to take a look at solution preparation. Solution preparation can take way by two means. We can dissolve some predetermined mass of solute, or we can simply take a solution of known properties and dilute it to the concentration that we need. Let's take a look at each one individually. Suppose you want to prepare a certain solution. In this case, 250 milliliters of 0.125 mole per liter copper chloride dihydrate. So the first thing I need to do is determine what mass I need of the chemical. I'll begin by writing down the known information. The mass I want to figure out, the volume I'm given, as well as concentration. I'm also given implicitly what the molar mass of my solute is, because I know the name of the substance. And in this case, it turns out to be 170.48 grams per mole. With knowledge of volume and concentration, I can determine the moles of my solute by using this equation. Before I substitute in here and solve, just a quick note about the units. My volume is in cubic centimeters and my concentration is in decimeters cubed. So I need to bring those into agreement. So there are 1,000 cubic centimeters in 1 decimeter cubed, hence 0.25 decimeters cubed. I'm going to rearrange this equation now to get the number of moles by itself on one side. So concentration times volume. The decimeters cubed units will cancel, leaving me with moles. Here I'm carrying one more significant digit than I need to, just because I'll round off at the end to the appropriate number. Once I have the number of moles, I can figure out the mass with knowledge of the molar mass. And to do that, I can calculate the number of moles times the molar mass will give me the mass of my chemical. The moles canceling, giving me grams. Now, there's a second way that I can determine the answer to this, and doing it in one step instead of two steps. There's the formula we have for concentration, number of moles over volume. I can replace the number of moles with mass over molar mass and come up with a new formula. Rearranging that formula to get the small m, or the mass, all by itself, I simply need to multiply the three together. Concentration times molar mass times my volume. So both methods work. Let's take a look at what this looks like. You begin by determining your mass of solid, in my case 5.33 grams, which I pre-weigh. That's then transferred to a beaker, and I also add about half the volume of liquid which I ultimately will need in my final solution. And I stir that mixture until the crystals dissolve. I then pour that into a volumetric flask through a funnel. I'll then rinse the beaker out several times with some distilled water and also add that to the volumetric flask. As you approach the final volume of your liquid, you might want to use a dropper to get it fine-tuned. Stopper the mixture and invert the container several times to adequately mix them. In my second method, I also want to prepare the same solution, 250 milliliters of 0.125 mole per liter copper chloride dihydrate. But this time I'm beginning with a pre-existing stock or known solution that's 1 mole per liter. So here I've listed that given information. So ultimately what I want to find out here is what volume I need of my stock solution, my initial solution, to make this mixture. Let's look at how this is going to take place. I have my stock solution, and I'm going to withdraw a certain volume of it that I need to calculate. That's then going to occupy a volumetric flask. Concentration times volume gives me the number of moles that I'm initially placing in that container. I add water to that container, and it reaches a new state where I have a new concentration and a new volume. And as a result, when I take the product of these two together, I arrive at the number of moles that are finally present in my container. Now, what's interesting in this case is the addition of water doesn't change the amount or the moles of solute that you add. They're just more spread out. So these two values must equal each other. So I'm going to start with that and derive an equation. So my number of moles initially must equal my number of moles finally. Hence, concentration times volume of my initial state must equal the concentration times volume of my final state. Rearranging this then to get the initial volume all by itself, and substituting and solving. The moles per decimeter cubed will cancel in this case, leaving me with centimeters cubed as my final answer. So in this particular case, it wasn't necessary to convert the volume. You could have, and here's what the answers would have been had you done that. Now, let's take a look at what this looks like also. You begin, as I say, with your stock solution. you carry out your calculation to determine the volume of stock solution that you need. So you transfer a bit of that stock solution to a beaker just to make it a little bit easier to obtain. And then you use a device, either a graduated pipette or a volumetric pipette, and withdraw the exact amount of solution that you need. That's then transferred to my volumetric flask. You might want to rinse out the pipette several times with distilled water just to ensure that you minimize transfer error. Then water is added to the mixture. Again, you might want to use a dropper to obtain the correct final volume. Stopper the mixture and invert several times. So those are a couple quick methods to prepare solutions. I hope you found that useful. Questions are always welcome.